Hello everyone, I will be demonstrating my final project for my robotics course, and in this project I worked with Ziyang Zhao, who was my partner. So in this project we created our own robotics visualization and control software in which you can control basically every aspect of this robot with our own app, with our own GUI, with our own software. We modeled each of these parts in the life-size model using SolidWorks. We're able to move that into MATLAB, and then with its GUI, we're able to display that, and then using inverse kinematics, then using Dynavit Hartenberg parameters, we're able to create a very robust application, a very robust software that maps all the different coordinate systems of all the parts and to make this an effective software. And to just show you what this can do, you can click initialize. You can see it is tracking the position in real time. It has gone to the home position, and as that is happening, you can see the actual motion on the GUI itself here. If I move this, so you can see that the robot and the GUI simulation is moving as well. Also, if I decide to cause it to relax, you can see that the robot and the simulation are also in sync as that happens. And you can also energize it at a different position. You can send it to different positions as well with the GUI. So for example, I'm just going to make everything -10. And you can see both the robot and the GUI moves to that position. You can see the transformation matrix being displayed here. So you can see the transformation at different points in time at the different angular positions that the robot is at as well. And some other functionalities, you can actually store different positions and teach the robot how to play a sequence of movements. So for example, if I relax the robot into a different position, set the move time to 2 and the acceleration to 0.5, store the point, and then I want to take it high and make it actually slower. I'm going to make it or slightly faster than this, 5 and acceleration 1, and store the point. Then I want to energize. It's an animate only button, so you can see how the robot will behave. So you can see, and now I'm going to play the sequence. So the robot is in the first stage. Now it's in the second stage, and finally it moved on to the third stage. And now back to the home position. You can store it, you can export and import different movements. So at each position the robot is, you can actually see the inverse kinematics, as I mentioned before. So you can first see the transformation matrix, and you can also see the inverse kinematics. So you can see that there are different solutions, but due to the different joint limitations, these two are not feasible positions. So even if they are correct mathematically, but in terms of physically in this current robot, they're not feasible. So let's go to one of the other feasible solutions. So you can put in, for example, with solution 2, and hit enter. I see the robot will move. So for example, you can hit solution 1, hit enter, and the robot will move to that position. So let's change these actually to a different move location. So say that with 25. Move to target. So you can see that quick movement. Now, I'm going to click compute inverse, so we can see all the different inverse kinematics positions. So we're going to move to solution 2, You can see the movement. We can move back to another solution. Then also, you can even see when there are infinite solutions at a particular point. So if I come here and I click compute inverse, you'll see infinite solutions possible because this z-axis is basically close to 1 at this particular position. Same thing if you move it upwards like this, because the robot has infinite solutions that it can go to at every point in time. So you can just keep going around, keep going around, keep going around. Same thing, anytime the z-axis is in the positive z direction or negative z direction. So yes.